Hello everyone! What I'd like to do in this video is just give you a ton more examples of graphing rational functions. So for each of these examples, before I go over them, if I don't remind you, I always want you to pause, try them for yourself, and then come back and we'll do them together. Okay, so just a few key things I want to talk about from our previous examples that help us graph these quickly. We want to think about the roots of these rational functions, their x-intercepts, and very similar to how polynomials behave, if those roots have even multiplicities, they'll bounce. If they had odd multiplicities, they'll cross through the x-axis. Now, you can always make sign charts to convince yourself of this. I highly recommend you do that, just so you're comfortable. When an asymptote has an odd multiplicity, it'll have opposite action on the asymptote. If the asymptote has an even multiplicity, it'll have like that volcano action, or it'll have the same action on either side of the asymptote. So putting those together, we should hopefully be able to graph these pretty quickly. But again, if you're uncomfortable kind of puzzling your way through these, I highly recommend making sign charts for these. Okay, first example. Okay, so let's say we want to graph r of x is equal to x squared minus 16 all over x squared minus x minus 2. Go ahead and pause the video and give this a shot. Okay, first thing we're going to do, first thing we're always going to do, we're going to factor. We're going to need to be being careful in the next section. If we don't factor ahead of time, we may miss out on holes. So we'll see what that when we get there. First thing I'm going to do, we're always going to factor first. The numerator is the difference of squares. Okay, and our denominator looks like that can factor to, I don't know, I need a combination of 1 and 2. And they need to add to a negative, so the bigger needs to be the negative number. Okay. Okay, so let's go ahead and start sketching things. So let's take a note here. Okay, so let's talk about where our x-intercepts are. Remember, our x-intercepts happen when the numerator is 0. So I'm going to write that up here. Our x-intercepts here, when the numerator is 0, mind that glare a little bit, yeah. So our x-intercepts, let's write these down. Well, that's when the numerator is 0, so we'll have an x-intercept at 4 and 0 and negative 4 and 0. Okay, so let's mark those. Beautiful. Okay. The vertical asymptotes, those happen when my function is undefined. That's when I'm dividing by 0. My vertical asymptotes will happen at x equals negative 1 and x equals 2. So here's negative 1 and here's 2. So we'll draw our vertical asymptotes. Okay. What else do we need? Okay, we need to know the y-intercept. That'll help us. The y-intercept, so I need to evaluate this function at 0, so r of 0. If I plug in 0, I'm going to get what? R of 0. I'm going to get a negative 4 times a 4, all over what? A 1 times a negative 2. What are we going to get there? What is that? Negative 16 divided by negative 2, so it looks like we're going to get out positive 8. Positive 8. So here's 8. And I believe that is all the features that we know about this graph. Horizontal asymptote. Horizontal asymptote. Okay, maybe I'll vertical asymptote, y-intercept, horizontal asymptote. Okay. Well, notice I have a degree 2 polynomial divided by a degree 2 polynomial. So they're tied in their war. So in this case, as x gets really big, they'll go ahead and they'll settle on the ratio of their coefficients. So my horizontal asymptote will be the horizontal line, y equals 1. So let's go ahead and jot that down. Okay, let's go ahead and graph this in red. Okay, what I'm going to do is, if I don't have to do a test point, I never will. I'm just going to see what we have here, and usually if I can figure out the action in one of these regions, I can piece the rest of the graph together. Okay, so what I'm mainly going to notice is I don't have any x-intercepts in this middle region. Okay, again, these two asymptotes partition my graph into 3 sections we need to fill in. And the first thing I'm going to notice, or at least the first thing that I notice, is that in the region between -1 and 2, the graph never crosses the x-axis. But I know when I plug in 0 and output is 8. So I know that in this region, at least for one output, it's 8. If it never crosses the x-axis, then it's never going to cross into the negatives. So I know the graph goes through here, and it really only has one option to do on either of these asymptotes. It has to approach them going upward. So this is me puzzling it together in the middle. Okay. So now let's see what's going on in these other regions. Okay, let's see what's happening on the left side of -1. Okay, so notice that this asymptote came from the x plus 1 term in the denominator. That has a multiplicity of 1. It has an odd multiplicity, so it's going to have opposite action. So if it's positive on this side, it's going to flip sign when we go to the other side. So I know it's got to be going down. Okay? Now I'm going to ask them my question. Well, I mean, without even looking at multiplicity, I can just think about what has to happen. Notice that the graph has to settle onto the horizontal asymptote. So there's no way that it could possibly bounce off -4, otherwise there would need to be another x-intercept for me to come back up. So the graph has to go through -4 and approach this horizontal asymptote. Okay, similar argument for, on the other side of 2. Notice x equals 2, that's where my function was undefined. This asymptote has an odd multiplicity, so it's going to have opposite action. Okay, so since it went up on the left-hand side, it has to be going down on the right-hand side. Okay, now let's look at 4. Okay, x, well, that has a multiplicity of 1. If I made a mistake before when I was looking for x equals minus, where it has to cross through, but also look at the root for that one. I'm sorry, the factor it came from has a multiplicity of 1. This had a multiplicity of 1, it crossed through. This root at 4 also has a multiplicity of 1, so it also has to cross through. So here's a nice, quick way that we can graph the rational function here. So here's a loose sketch of the graph. How fun is this? Okay, let's do another one. Okay. So let's say that we have r of x is equal to, how about a negative x squared minus 2x, how about plus 8 all over, how about all over an x squared minus 4x? Okay, go ahead and give this one a shot. Okay, let's go over it. First thing we're always going to do, if it's not already factored for us, we're going to want to go ahead and factor it. Okay, first thing I'm going to notice, in the numerator, I'm going to factor out a negative. So I'll factor out that negative, and I'll be left with x squared plus 2x minus 8. Okay, in the bottom, I can factor out an x. So I'll be left with the negative. Okay, what am I going to get here? I think I'm going to get an x. I think I need an x plus 4 and an x minus 2. Okay, these multiply to give me -8, and they add to give me 2. Sweet. Okay, all over x times x minus 4. Beautiful. This is our polynomial in factored form. Okay, let's go ahead and write that up here. So I have a negative x plus 4 times an x minus 2 all over an x times an x minus 4. Sweet. Okay, so let's graph this. Okay, first thing to note, let's think about the x-intercepts. So the x-intercepts, okay, that happens when the output of my function is 0 and a fraction is only 0 when its numerator is 0. So my x-intercepts will happen at -4, 0, and 2 and 0. So let's mark those. So here's -4 and here is 2. Okay, so the graph goes through here. Okay, I have a vertical asymptote. Ooh, let's use a different color for this one. Let's maybe we'll use red. Sure. Okay. So just so to look at the axis. Notice I have a vertical asymptote. Our vertical asymptote, that's when x equals 0, and also when x equals 4. Okay. So I have another vertical asymptote here. Okay. What else do we know? Let's think about the y-intercept. We'll notice that the y-intercept, if I try to evaluate this function at 0, well, notice I'm going to be dividing by 0. If I plug in 0, I'm going to get a 4 times a -2. So I'm going to get what? A -8 all over 0, because I'm going to get 0 times -4, which is 0. There's no y-intercept. And we can think about why there's no y-intercept here. Well, we have a vertical asymptote here. So the graph is not going to hit the y-axis. Okay, and now let's talk about, we have our vertical asymptote. Let's talk about our horizontal asymptote. Okay, a horizontal asymptote. Well, they are tied in the war. They're both second-degree polynomials, so they'll settle on the ratio of their coefficients, which would be a -1 over 1. So the horizontal asymptote will be y equals -1. So here's a -1. Okay, let's go ahead and draw our horizontal asymptote. Okay, let's go ahead and piece this together. Okay, the very first thing I'm going to notice is over here. There's no x-intercepts. No x-intercepts at all. So I know that the graph cannot possibly be approaching the this vertical asymptote from the right above, because if it did, it would have to come back down and settle on its end behavior, which would be this horizontal asymptote at x equals -1. So it has to be doing this. It has to be approaching like this. I have to be doing this. Okay. There's no x-intercepts over here. There's no possible way it could do this. Okay. Let's see here. Let's look at the multiplicity of this one. Okay, so when I'm on one side of 4 and I go to the other side, the x minus 4 term, it has a odd multiplicity, so it'll flip sign. So if it was negative down here, it'll become positive up here. So, okay. So let's see what's going to happen. Okay, well, does it cross through to, or does it bounce? Well, if I look over here at x minus 2, notice that it has an odd multiplicity. So if I'm positive on the right side of 2, it's going to flip sign when I go to the left side of 2. This factor will flip sign. So if it was positive, when I go over here, now it'll be negative. Okay. So now what's going to happen? Well, notice it can't possibly go back up. There are no more x-intercepts here. So what it's going to do is it's going to come down and cross here. Now, a question you might have is there a problem that I cross this horizontal asymptote? No. There's no problem that I cross the horizontal asymptote. Remember what the horizontal asymptotes are. They are the end behavior of the function. So my function just has to be approaching this horizontal line here at the ends. It's okay if it crosses in the middle. It's not a problem at all. Just as long as my function rests and settles on this horizontal asymptote at its ends, it can cross it in the middle. Technically, I actually don't know. Just to kind of say, we're just drawing rough sketches. I don't know. It's very possible that this could come above and could settle down on the top of this horizontal asymptote. But it's going to do one or the other. But again, these are just loose sketches. So they don't have to be super accurate. We just want to know the general behavior of these functions. Okay. So now what's going to happen on the left side of 0? Well, notice that the asymptote x equals 0. Notice it has an odd multiplicity, so it's going to have opposite action. So it has to do this. Okay, so it's going to flip sign on, x is positive on this side, x is negative. So when I'm on the negative side, well, if it was negative over here, it's going to flip to being positive over here. Okay, so this is going to come down. Now I know it's going to have to cross through at -4. It has to because it has to settle on our end behavior. There's no way it could bounce. There's not enough x-intercepts for it to be able to come down and rest on the end behavior on the line x equals -1. So this is what the graph has to look like. Beautiful. Let's do another example. Okay. Okay, let's try this example. Let's say we have r of x is equal to, how about x minus 3 squared and x plus 2 all over an x minus 1 squared times an x minus 2. Go ahead and pause the video and give this one a shot. Okay, let's do it. Okay, so let's see what we have here. Let's look at the x-intercepts first. Okay, the x-intercept is where the graph is 0. So I will have x-intercepts looks like at 3, 0, and also at -2 and 0. And if you'd like, we could record the multiplicities of these. This has a multiplicity of 2. This has a multiplicity of 1. Okay, let's look at our vertical asymptotes. Okay, we have a vertical asymptote. That's where my function's undefined. So I have one at x equals 1, and you could say this has a multiplicity of 2. And it looks like I have another one at x equals +2, and that has a multiplicity of 1. Okay, what else do we know? How about the y-intercept? Okay, what happens if I plug in 0? If I plug in 0, let's see, r of 0, I'm going to get -3 squared, so I'm going to get, what, a 9 times a 2 all over a -1 squared, so I'll get a 1 times a -2. Okay, looks like the 2 and those 2's cancel. I believe I'll be left with a -9. Okay, let's mark that. -9, graph crosses here. Okay, what else do we know? We have a x-intercept at 3. Okay, we have an x-intercept at -2. Okay, we have a vertical asymptote at x equals 1. It's good to draw these in red. Okay, we have a vertical asymptote at x equals 2. X equals 1, x equals 2. Okay, let's change the scale a little bit. Just make it a little bit clearer. Let's change the scale. Okay, so let's say this is 1, let's say this is 2, and let's say this is 3, -1, -2, -3. Okay, I had a x-intercept at 3. So I got an x-intercept here. I got an x-intercept here. I have a vertical asymptote at x equals 1. I also have a vertical asymptote at x equals 2. Okay. I have a y-intercept at x equals -9. And what else do we know? Let's think about the horizontal asymptote. Okay, well, notice here that this is a degree 3 polynomial. If you were to expand this, its leading term would be x cubed, and it would also be an x cubed at the bottom. They'll settle on the ratio of their coefficients, which will be 1 over 1. So we'll have a horizontal asymptote of y equals 1. 1. Okay. Let me erase some of this so we have a little bit of room. Okay. Okay. Okay, so what do we know? What do we know? What do we know? Okay. Well, what I do know is that the graph has to cross through here. The graph has to cross through here. Okay, notice that it wouldn't be possible for me to be approaching the asymptote from above on this one, because if I came down, well, it has to hit the -9, and there's no x-intercept here. So I know right off the bat it has to do this. it has to do this. Okay? So is it going to cross through -2? Is it going to cross through -2? Yes, it has a multiplicity of 1. It'll cross through and it'll settle on its end behavior. So the graph has to be doing something like this. Okay, so x equals 1. X equals 1 has a multiplicity of 2, so it's going to have the same action on both sides of these asymptotes. Okay, so if this graph was going down here, it also has to be going down here. So when I'm between 0 and 1, I know the value has to be negative. The value has to be negative, and it's not going to flip sign when I go to the other side of 1. So on the left-hand side, x minus 1 would be negative, but I'm squaring it. When I'm on the right-hand side of 1, this x minus 1 factor will be positive, and I'm squaring it. This will change. This will stay positive when I'm on either side, so it's not going to flip. It's not going to flip sign and go to the other side. So we'll have the same action around this x equals 1 asymptote. Okay, there's no x-intercepts in here. It can't cross back up and do this. It can't cross back up and approach upward on this asymptote. It has to be going down. Okay, let's think about the multiplicity. The multiplicity here for the x equals 2 asymptote has a multiplicity of 1, so it'll have opposite action. So it's got to be doing this. And is it going to bounce off 3? Aha, it has a multiplicity of 2. It's going to bounce. How fun is this? How fun is this? Boing! Awesome, and here's our rough sketch of that of this rational function. I just love puzzling my way through these. I don't know, I just think it's fun. So, all right, let's do more. Let's do another one. Okay. Okay, let's see. Let's try this one. This one looks good. So let's say we have r of x. Let's say this is 3x squared plus 6 all over, how about x squared minus 3x minus 2x minus 2x minus 3. Okay. Go ahead and pause the video and give this one a shot. Okay. So first thing I'm going to do is we're going to try to factor this. Okay. So let's see what we can do. Looks like all I can do here is factor out of 3. So let's factor out of 3. I'll get an x squared, what? An x squared plus 2 in the numerator. Okay, in the denominator, how will this factor? Looks like I'll get some sort of combination of 3 and 1. I need a negative on the bigger number. Okay. Now notice I can't factor this any further. I can't factor this any further because x, it's x squared plus 2. And I guess the reason I can't factor this any further is, well, x squared plus 2, when is that equal to 0? Well, that's when x squared is equal to -2, or when x is equal to, what? Plus or minus the square root of -2, or that's when x is equal to the plus or minus 2i. So in this case here, I have imaginary roots, and while this will factor, I guess it will factor to x minus 2i and x plus 2i, but if we're graphing this, we don't care about the imaginary roots, so this won't factor any further. This is as far as I can go. But what I hope I've just shown you here is there's actually no x-intercepts. So x-intercepts. You'd be asking yourself the question, when is x squared plus 2 equal to 0? Well, that's when x is equal to plus or minus 2i. This is telling us that there are no x-intercepts. Bummer. That's okay. We'll get through it. Okay, let's look for our vertical asymptotes. Okay, our vertical asymptotes will happen at x equals 3 and x equals -1. They'll both have multiplicities of 1. Okay, let's look for the y-intercept. Okay, the y-intercept, if I plug in 0, this looks like r of 0 will be, what, 6 over -3, so we'll get out a -2. So our y-intercept is 0, -2. And the last thing is, let's talk about the horizontal asymptote. Okay, well, they are tied in the war, so they'll settle on the ratio of their coefficient. So y equals 3 will be the horizontal asymptote. Okay, let's throw this together. All right. So no x-intercept, bummer. Okay, vertical asymptote at x equals 3. So here's 3. Okay, it looks like x equals -1. Okay, let's see, our y-intercept's at -2. -2. Okay. Okay, and what else do we know? We have a vertical asymptote at y equals 3, or the line y equals 3. So here's 3. I have this horizontal asymptote. Okay. So let's think about what has to go on with this example here. Okay, well, we could hopefully see that on both the right and the left-hand side, well, there are no x-intercepts. And I have to settle on my end behavior here, so there's no way that the function could be negative and possibly come up to settle on the end behavior because I'd have to cross the x-axis. There's no x-intercepts, the graph has to be doing this. You can make that same argument over here, it has to cross through -2. There's no x-intercepts, so the graph has to be doing this. Now this also is agreeing with the multiplicity of this asymptote. It has a multiplicity of 1, so I should have opposite action on either side. And over here there's no x-intercepts, so the graph has to be doing this. And I should have an odd multiplicity for x equals -1 asymptote. Boom, 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 it's a 1, sweet. Boom, there we go, there's our graph. Notice I didn't have to make a sign chart, just kind of puzzling our way through it. There may be situations where you might have to probe a point here and there, but once you figure out usually the behavior on one side of an asymptote, you can quickly figure out what's going on the other side. Okay. Let's go ahead, let's do... see, I had another good example in here. Let's do this one. Okay. Okay, so let's say r of x. Let's say r of x, let's say it factors to, how about x plus 2 squared all over, how about x squared times x minus 2 times x minus 5. Go ahead and pause the video and give this one a shot. Okay, let's do it. Okay, let's write down our x-intercepts. So our x-intercepts are going to happen when values of x make the output 0. So that's when the numerator will be 0. So x equals -2 will be our x-intercept. Or how about I write this as it's going to be -2, 0. And it has a multiplicity. It has a multiplicity of 2. Let's look at our vertical asymptotes. Okay, we have a vertical asymptote at x equals 0. It has a multiplicity of 2. I also have one at x equals 2, and it has a multiplicity of 2. I also have an asymptote at x equals 5, and m equals 1. M equals 1 for this one, and x equals 1 for this asymptote. So those are the vertical asymptotes and their multiplicities. Okay, y-intercept. Well, if I have a vertical asymptote at x equals 0, I shouldn't have a vertical if I have a vertical asymptote at x equals 0, I shouldn't have a y-intercept. We can check that by trying to plug in r of 0. Notice in the numerator, what am I going to get? 2 squared, I'm going to get 4 divided by 0. The 0 will 0 everything out. So no y-intercept. No y-intercept. Okay, let's also look at our horizontal asymptote. Okay, our horizontal asymptote, well, I have a degree 2 polynomial divided by a degree 1, 2, 3, a degree 4 polynomial. The denominator is winning the war. So in this case, my horizontal asymptote will be the x-axis. So horizontal asymptote will be x equals 0. The denominator is winning the war. Okay, let's sketch this. Okay, so I have an x-intercept at -2, 0. Okay, I have a vertical asymptote at x equals 0. So I have a vertical asymptote here. I have a vertical asymptote at x equals 2. Okay, and also one at x equals 5. Sweet. Okay, so this is what we know so far. Oh, and we have our horizontal asymptote here. Okay, so what can we do with this one? Well, at least when I look to the left, or at least what I'm noticing, is that I don't necessarily know if the graph is going to go this way or this way. I know it's not going to cross through the x-axis anywhere over here, so the graph either has to be doing this or be doing this. It has to be an upward parabola or a downward parabola in here. Same thing over here. So, and even over here, I mean, I'm having a hard time telling what's going to happen. I don't know if it's going to be going up. I know it's going to have to bounce off. I know it's going to have to bounce. So I don't know if it's going to bounce and settle back down or if it's going to go like this. So what I need to do is I have to do a test point. And you could do it anywhere if you'd like. Let's do a test point. I know, let's figure out what's going on over here. So at a number bigger than 5, the graph is always going to be positive or it's always going to be negative because there are no x-intercepts for me to be able to flip sign. So let's just pick a number, I don't know, bigger than 5. I don't know, how about when x equals 100? What happens if x equals 100? Well, if I plug in 100, I'm going to get 100 plus 2 squared. Well, that's going to be a positive number. Okay, if I take 100 and I square it, I get something that's positive. If I take 100 and subtract 2, I get something positive. If I take 100 and subtract 5, I still get something positive. So if I plug in 100, I'm going to get out a positive value. So I know the graph is always positive over here. So the graph has to be staying above the x-axis from 5 on. So that's what the graph has to be doing. Okay, now I'm just going to look at the multiplicity for this asymptote, x equals 5. Here it has a multiplicity of 1, which means it's going to have opposite action. And I know since there are no x-intercepts here, it has to come up and come back down. Okay, there's no way it could cross through and have the asymptote approach positive infinity when I'm on the right-hand side of this asymptote x equals 2. Okay, similar thing. Okay, let's look over here what's going on at the asymptote x equals 2. Okay, well, in this case here, I'm going to have opposite action because this has an odd multiplicity. So the graph has to be doing something like this in this region. It's to be doing something like this. Okay, again, there's no x-intercepts. So it's either always going to be positive or always going to be negative, but we know since it's negative over here, it's going to flip sign because I have an odd multiplicity here. Okay, now around x equals 0, I have an even multiplicity, so it's going to have the same action on both sides of the asymptote, so it has to be doing this. It's like a volcano right here. So it's going to come down. Okay, is it going to bounce off this root or is it going to cross through? Aha, it's going to bounce. It's going to bounce. It has a multiplicity of 2. Boing! Okay, now it's going to bounce, but it's got to come back down and settle on the end behavior. How fun is this? So here's the graph. Okay, let's do one more. Okay, let's say we have that r of x is equal to, how about it's x minus 4 times x plus 2 squared all over, how about an x minus 1 to the 4th times an x plus 4. Okay, go ahead pause the video, give this one here a shot. Okay, let's do it. All right, let's look for the x-intercepts. All right, our x-intercepts, well, I'll have one at x equals 4. It'll have a multiplicity of 1. I'll have one at x equals -2, and it has a multiplicity of 2. Let's look at our vertical asymptotes. Our vertical asymptote will be at x equals 1 and also at x equals -4. This one has a multiplicity of 4. This one has a multiplicity of 1. Okay, let's look at our y-intercept. Okay, so we need to evaluate our function at 0. If I plug in 0, what am I going to get? I'm going to get a -4 times 2 squared. I'm going to get another 4. Then I'm going to get a -1 to the 4th, so that's a +1 times another 4. So it looks like the 4's cancel, and I'm left with -4. So I have a y-intercept at 0 and -4. Okay, let's look at our horizontal asymptote. Our horizontal asymptote, well, this is a degree 1, 2, 3. It's a 3rd degree polynomial on the top. 4, 5, this is a 5th degree polynomial on the bottom. The bottom is winning the war. The bottom is going to dominate. So as x gets really big, this function is going to get sucked down to 0. Okay, so y equals 0 is our horizontal asymptote. Okay, x-intercepts at x equals 4. 1, 2, 3, 4. Okay, at -2. Okay, looks like our vertical asymptote at x equals 1. We have one at x equals -4. -4. And we have our horizontal asymptote y equals 0, and our x-intercept, our y-intercept is at -4. Beautiful. Okay. So let's piece this one together. What could we do? Well, what I know has to happen looking at this y-intercept here, I know that the function is negative over here. When I plug in 0, I get something negative, but there's no x-intercepts over here. So once it's negative over here, at least in this region, it has to stay negative. So the graph is going to do this. So it has a possibility of flipping sign about -2. Well, is it going to bounce or is it going to cross through? Well, since this piece is being squared, it's going to bounce. We have a multiplicity of 2, so it's going to bounce and it has to come back down. Again, there's no extra intercepts for it to come back up. Okay, from here we can just start thinking about the multiplicity of the asymptotes. So when x equals 1, this asymptote, x equals 1, has a multiplicity of 4. We're going to have the same action on both sides. So it's got to come up, okay? Is it going to bounce or cross? Look, it has to cross through. It has a multiplicity of 1. This 0 has a multiplicity of 1. So it's going to cross through and it's going to come back down and settle. Okay. And for x equals, so the -4, x equals -4 asymptote that has a multiplicity of 1, it's going to have opposite action. Whew. And there we go. There we have it. I hope these examples were helpful. Lots of practice, lots of puzzling, lots of fun. We'll see you in the next video. Take care.